This presentation is about electrochemistry and specifically what is redox and what kind of reactions they are. A redox reaction is a specific type of chemical change or chemical reaction in which the oxidation state of elements change. Oxidation state is nothing more than a fancy word for charges. So when you're looking at an element, for instance, you might be going from iron in a +2 state to iron in a +3 state. That would be part of a redox reaction when you change the overall charge of the elements. And you have to have one element is going to lose electrons and one element is going to gain electrons. Some of the questions you're going to be asked when dealing with a redox reaction is you're going to be asked to label things as oxidation or reduction and identifying which element is losing electrons and which one is gaining them. So here are two mnemonics to help you remember which is which. You could do oil rig or Leo says grr. In oil rig, oxidation is losing, reduction is gaining. So that means that the element that loses the electrons is being oxidized and the element that is gaining electrons is being reduced. Leo says grr. The Leo portion is losing electrons as oxidation, and that stands for, you can see the L, the E, and the O is the Leo, and the grr says gaining electrons is reduction. So pick one of the two mnemonics and be able to understand by looking at a reaction which one is gaining electrons and which one is losing electrons. Alright, so what you end up doing is you get an overall equation and you're going to be breaking it down into half reactions. And half reactions allows you to identify or isolate the portion that is doing the oxidation and the portion that is doing the reduction. So the portion that would be losing electrons and the portion that is gaining the electrons. So you're going to have to look at an equation and identify, okay, what are the charges that are changing here? Anytime you have an element by itself, it has an overall oxidation state of 0. So our hydrogen and our oxygen are both in a 0 state. But in water, we have hydrogen combined with oxygen, and our oxygen is a -2. It's always pretty much -2 in a compound, but it can be forced to do other things. And in this case, our hydrogen is +1. So we have in one half of the reaction, we have H2 forming those H+ ions, and then we have our oxygen, or O2, forming the O- ion. And as you can see, in order to balance the charges, you have to add electrons. So, to balance out the electrons and the charges in the first reaction, you have to have 4 electrons. And in the second equation, you have 4 electrons as well. That's because this whole reaction is balanced. If you look at your H2 forming H+ ions, you are losing electrons because it is a product and they are being given off. So if we're losing electrons, that's oxidation. In the second equation, you can see that the electrons are going into this reaction. So we are gaining them, and that is reduction. Okay. There is some confusion depending on the language of the question. If it's asking you about an oxidizing agent or an oxidant, that is the one that makes it possible for something to be oxidized, so the one that is being reduced. And if they're asking you about a reducing agent or a reductant, that is the one that's making it possible for reduction to occur, so it's the one being oxidized. Think of these as opposites. But be careful, make sure that you are reading the words that are in the problem. Back to an earlier mention I made, these equations are balanced. You can see that we have, here I'll even do it in blue, you can see that you have 2 hydrogens, 2 H2s here, and you have 2 here. The elements have to be balanced as well as the charges have to be balanced in a redox reaction. So part of your potential issues that you could have in doing these problems is not making sure that the atoms themselves are balanced in one of the initial steps. So keep that in mind when you're doing redox reactions. Some redox reactions are pretty simple and you can balance them just by sight. And that's the ones we're going to look at initially. But there will be some that you will have to have a more complex process in order to balance. And that is something we're going to get into in a couple of days in class. It's called Balancing Redox Reactions, and it'll take multiple steps. But the ones we're looking at here today are not nearly as bad. You can see the half reaction here. We have this first one, we have zinc. This first one, we have zinc forming zinc plus 2 ion and 2 electrons. And then we have our second one, we have H2 ions and electrons forming H2 gas. One is oxidized because it is losing electrons, and one is reduced because it is gaining electrons. When you put them together and then you cancel out the electrons, you end up with this overall reaction for this oxidation and reduction process. You can look at this equation and see that it's in ion form, and that's fine. The spectator ions have been canceled, it's a net ionic, but you could easily balance this one by sight if I gave you the original equation and said balance this, so it's no big deal. Some of these, like I said, are going to take many more steps, and we'll get into that in a bit. Okay, here's a sample redox reaction that we can look at, break it into half reactions, and balance it. You could probably balance this one by sight. We would see that we don't have our NO3s balanced, and we know that we're going to need to put a 2 there, and then we'd have to put a 2 here, and that's easy to balance. But what I'm asking you to look at this reaction is realize that there's some charge changes, and this is actually a redox reaction. So let's see if we can break this into its half reactions. We have our copper in a 0 charge, and we have our silver in a 0 charge. It's sometimes a little bit easier to recognize that this is a spectator, and so our copper or our silver is a +1, and this is a spectator, and so our copper over here is a +2. So now we can actually see that our charges are, we're going from a 0 charge, so let me rewrite this. We're going to rewrite our copper is going to copper in a +2 charge, and our silver is changing to a, well, it's a silver ion, is changing to a silver solid with a 0 charge. And if you want to write in those 0 charges, it's not going to do anything, not going to harm any of the process. So the next step, we have our half reactions here. Our next step would be to make sure that our elements are balanced, and they are. And we need to then make sure that we have our electrons balanced. So I see that my copper is going to a +2. So in order to balance that out, my left side has 0 overall charge and my right side has +2. So I'm going to add 2 electrons to the right side. And then I see in my silver's case, I need to add an electron to the left side. Now, if I wanted to take this a step further and say, okay, which one is oxidized and which one is reduced? Remember, oxidation is losing. So up here, my losing side, this is oxidation. And reduction is gaining, so this is reduction. Now, if we wanted to, go ahead and balance this, one of the key steps that we haven't really investigated is we need to have the same number of electrons. So in order to do that, you can see that, we only have 1 here and we have 2 here, so we'd have to multiply this whole reaction by 2, which is how you get your end overall reaction of Cu. Here, I'll write that in black, it's a little bit easier to see. Cu plus 2 Ag pluses makes Cu plus 2 and 2 Ags. And you can see how I got that from the individual steps. The biggest key with doing this whole process is keeping track of your charges and watching your atoms. And if you can do those 2 things, the rest will fall into place.